Hello everyone and welcome. This is Mario Chappara, founder of Lean Life Cycle. In this presentation, I'd like to walk you through the Lean Life Cycle concept. So, what is the Lean Life Cycle concept? The Lean Life Cycle concept is a combination of lean thinking and life cycle thinking. Let us see what these two methodologies bring together to the table. Lean was primarily incepted in manufacturing to identify and eliminate waste from manufacturing processes, whilst life cycle thinking helps us go beyond the traditional focusing of only the production side of things and also includes the environmental, the social, and the economic impact of a product or service over its entire life cycle. So, what is the aim of the lean life cycle concept? The aim is that of bringing lean and life cycle together to eliminate waste from our processes, incorporating all the life cycle steps other than only manufacturing ones to make our process more environmentally friendly, cost effective, and therefore sustainable in the long term. So let's take a look at some background at how we can achieve environmental sustainability in product life cycle. What is a process life cycle? A process life cycle incorporates all the stages in a process making up a product or a service from inception till the end of life. For example, the concept, starting from the concept, the design of a service or of a product, the raw material extraction needed for the manufacturing of a product, the development, manufacturing, the distribution, the acquisition, the operation of a service or of a product, the use of that product during its lifetime, the maintenance of that product to keep it going, the decommissioning of a service, or the disposal of a product at the end of life. So, assessing a process life cycle. If we cannot measure a process, we can never improve it or make it better. The life cycle assessment tools of ISO 14001 help us measure the impact of processes from an environmental perspective. So, what are the steps involved in this? First of all, we have the goal and scope to identify the boundaries of the process that we are going to measure, that we are going to assess using the LCA tools. The inventory, making up that process, for example, the raw material needed for a product, the distance traveled to deliver that product, the energy consumed during the process, the water used during the process, etc. And third is the impact assessment, which is obtained by inputting the inventory data in the second step into the LCA software to compile and get out the environmental impact assessment from the process. Each assessment must have its goals and scoping, which is what process stages are we going to include in the assessment. We can have an assessment of a whole life cycle of a product or service from cradle to grave, which incorporates most of the stages that we have seen: concept, the design, raw materials, production, delivery, the use of the product, the disposal of such product. We can have a full boundary, a full circular boundary, which incorporates circular economy, whereby during disposal the product itself is used as raw material to make another product. We can have the cradle to gate process, which incorporates the process from inception till the production stage, till till when the product is at the gate for distribution by consumers. And also we can have a sub-life cycle, a single stage, which would be just one stage out of all the full processes that we have seen above, which sometimes can yield more immediate results. Doing an impact assessment of a whole life cycle can be lengthy, can be disheartening, so it might be wiser and more feasible to analyze a single stage at a time and do a continuous improvement cycle to finally achieve an improvement of the whole cycle. So, how to achieve sustainability? What are the steps? The first step is to identify the impact of the current process. So, set the scope of the process, map the process, get full governance of your process, measure its inventory, compile the assessment, and identify where the most impact is, where there are the most waste points. The second step, improve the identified waste points. Using lean tools, we can improve certain stages with most waste, like for example, where we have a lot of inventory, we can reduce that inventory by using just-in-time or the pull Kanban. Or for example, where we have most defects, we can do error proofing tools for quality control to reduce the defects and the rejects, which is all considered as waste. Or perhaps where we have a lot of manual intervention, where there are decisions prone to error, or human checks, or human bottlenecks, we can digitize the process to eliminate that human intervention. The third step, reassess the improved process. Compare the reassessment with the original assessment. Identify impact differences. Did we improve the process? No. Can we improve it more? Can we skip to something else? And plan the next improvement iteration. Number 4, reiterate for continuous improvement. As we have seen, we can focus on one stage. Once we improve that stage, we can focus on another stage. It's very hard to improve a whole process using 1 or 2 iterations, so it has to be a continuous improvement. Also because some processes evolve according to their context or the environment they are implemented in. So basically we need to continually improve the process and make them evolve so that we can attain sustainability in the long term. How can we help as Lean Life Cycle? We can help you identify your environmental impact by primarily helping you identify each step of your process, perform process mapping, and set the assessment process boundaries of what you want to improve. We can audit the process to quantify the life cycle inventory. We help you decide which part of the process is best to improve. For complex process cycles, we help you look at the verticals by focusing on smaller sub-process cycles, which means that we help you identify which is the best stage in your process to start with or to focus on for initial assessments. Or perhaps we help you re-engineer the whole process to make it simpler if it's a very complex one. We compile an LCA report based on ISO 14040 standard to quantify your environmental impact for that process. We help you identify the real waste points for long-term improvement. And we also help you identify the quick wins for immediate improvement results. Sometimes we have low-hanging fruits which are in front of us, which we can do immediately to improve the process drastically, and then focus on the real hard things to improve. What are we going to achieve together by improving our process? Using the identified waste points, we help you with the process reengineering. We help you to introduce lean tools in your processes to improve the bottlenecks causing the most waste. We help you with digital transformations if there are manual interventions which need attention, which are causing delays, which are causing bottlenecks, which are causing impact or waste. We help you choose the right solution and partner if needed. We help you compile an improved process map with the desired inventory levels for improvement. And we also assist you during improvement implementation. What to achieve for environment sustainability? Following the improvement implementation, we compile a reassessment LCA based on the improved process. We compare and interpret the results. We suggest and plan next improvement iterations. We provide the necessary documentation for ISO 14001 certification audits. We also help you identify and reach sustainable development goals that are applicable in your process and also define the roadmap on how to achieve them. And following all this, we provide the necessary documentation for green financing and for financial sustainability. Last but not least, we assist you throughout all your journey, but we believe that the best thing for long-term sustainability is that of empowering our clients, help them get into the habit, into the culture of continuous improving their processes, and also that of upskilling their resources so that the improvement of their processes will always be maintained. Therefore, we offer training on life cycle thinking, life cycle analysis, lean thinking, and above all, that of using the lean life cycle framework that we have seen in this presentation. I would like to finally walk you through the results of a case study where the lean life cycle was applied. This was a construction case study based in Benidorm Beach, Spain, on a 36-story building. For this case study, as we have seen at the beginning, the assessment scoping was done only for the concrete pour phase. As one can imagine, the whole life cycle of a building can be complex, can be quite lengthy, and we decided to focus only on one stage, that of concrete pour, which was a stage that basically had a big impact on the environment due to the concrete. So we decided to focus only on this stage. These are the process mapping and inventory recordings of the original and improved process, where we mapped the concrete pour process and recorded the inventory inputs of each process step. As one can see, there is a 7-day wait between the concrete pour and the shattering removals in the original process, and we decided that we should try to reduce or eliminate the waiting time and make it shorter. So basically, from the original process to the improved process, there was an improvement of around 90,000 kilowatt hours from the original process to the improved one, which is that of 190,000 kilowatt hours to 85 kilowatt hours, amongst also other improvements in other inventory categories. So when we looked at the waste point between the concrete pour and the shutter removal, we understood that the weight was due to the results being sought from the concrete laboratory. So we decided to implement a concrete monitoring system to know real time how the concrete is behaving, how the curing is behaving, and know real time when the concrete would have reached the desired strength, which is that of 25 megapascal. So we decided to implement a concrete monitoring system. We implemented Cosmos, we partnered with Cosmos. As you can see here, there are some photos. This is the monitoring gateway for a number of concrete sensors. This is one of the concrete sensors embedded in the concrete. This is another gateway. And these are the results for the improved process over 13 concrete pours for which readings were recorded. If one looks at the graph, the 25 megapascal depicted by the orange line is surpassed between day 2 and day 3, which means that works can resume as early as day 3 instead of the normal 7-day wait. So this helped us move on to shutter removal quicker than having to wait for 7 days, with the consequence of having this improved impact assessment. These are the environmental assessment reports for the original process on the left and the improved process on the right. As one can see, the biggest improvement was that of CO2, with a change from 257 tons of CO2 to 223 tons of CO2, an overall improvement of 13.14% on that concrete pour phase, which is quite a good improvement, encouraging result. The key findings on this case study were those of having a reduction in a cycle time of 71.4%, equivalent to 5 days, a reduction in CO2 over one concrete pour cycle, equivalent to 33,774 kilograms of CO2, as we have seen in the impact assessment report, and an overall building estimation reduction of CO2 of 2.62%, equivalent to 1,208 tons of CO2. So this is all from my side. Thanks for listening to my presentation. For more information, I suggest you visit our website www.leanlifecycle.com. Leave us a message, make contact with us for more information, and for also collaborating with us to discuss with you, give you a free consultation, see what processes you need to improve, and start the journey together. Thank you.